Okay, so in this lesson we're going to talk about how to find the volume of a prism. So if you recall from the video you watched for homework, where we named the different prisms, it talked about what a base is of a prism. So remember, the base is one of the two sides that are parallel to one another, and they're congruent. They have the exact same side length, they're the same shape. So those two, in this particular prism here, we have the base highlighted. So those two are parallel to each other, they're congruent, they're called the bases. And then remember, the height is just what connects the two bases together. So it's the edge of the prism that connects the two bases. So for the volume, to find the volume of a prism, we're going to take the area of the base times the height. And that's how we write that. Volume is capital B times H. Now that capital B is representing the area of the base. It's not just saying the base length like in a 2D figure. It's that capital B is purposely capital rather than lowercase because it's referring to the area of the base. And then you take that answer times the height of the prism. So let's see how that works in an example here. So I have this prism, which, by the way, let's just decide what kind of prism it is using your vocabulary from the other night. So I can see that we have a triangle here and a triangle in the back, and those are congruent. They're the exact same shape, and they're parallel to one another. So those are the bases of this prism. So because those are the bases, we know that this is a triangular prism. And we know that the height of the prism is the side that connects those two triangle bases. So let's go ahead and find the volume of this prism. So we're going to take the area of the base times the height. So the base, we said a moment ago, is a triangle. So we remember that to find the area of a triangle, we take the base of the triangle, which would be 4, times the height of the triangle, which would be 6, and we divide that by 2 or multiply by 1/2. So that's going to give us capital B, the base area, and then we're going to multiply that by the height of the prism, which is 8. So 6 times 4 is 24. We'll divide that in half, and we'll multiply by 8. So 24 halves is 12 times 8. 12 times 8 is 96. And these are centimeters. And remember, we're talking about volume here, so that's going to be in centimeters cubed. So the volume of this figure, this triangular prism, is 96 centimeters cubed. Now keep in mind, when we're talking about volume, we're talking about filling up this prism. So if I filled it with sand or water or some kind of substance, that's what we just calculated. So this particular prism holds 96 centimeters cubed of something. Let's take a look at another example. So we have another triangular prism here. I can tell that because the bases are triangles. So volume is area of the base times the height. So the area of the base is a triangle. It's a right triangle. So I'm going to take the base, 6, times the height, 8, I'm talking about of the triangle, divided by 2. And then remember, to figure out the height of the prism, it's the segment that connects the two bases. So that has length 9 in this particular case. So we have 6 times 8, which is 48 halves, times 9. 48 halves is 24. And we're going to multiply that by 9. So 24 times 9 is 224 times 9 is 216. And these are feet. And we're finding volume, so that's feet cubed. Okay, let's look at the next one. All right, so this says all surfaces are parallelograms. So we have this prism here with parallelograms for bases. Notice it's slanted. We call that a slanted prism, but that doesn't matter. We're still going to use the same formula. So that's area of the base times the height. Now, I have to decide what the base is for this prism. Well, they're all parallelograms, so I really could use any parallelogram as the basis. However, I have to look to see where I know information. Parallelogram area is base times height. So we have to look to see where do we know the base and the height, which parallelogram. So I'm seeing the top and the bottom have the most information. So let's decide that the top and the bottom we're going to use as the bases. So area of the base, area of the parallelogram, top and bottom. I see this 3 segment here is marked perpendicular, so I know that's the height of the parallelogram. So that's part of it. And then I want the base length for that parallelogram. Well, it's not marked on the bottom parallelogram, but it is marked on the top parallelogram. So I'm going to substitute 15 in for the base of the parallelogram times 3, which is the height of the parallelogram. Now we want the height of the prism. Remember, that's the straight up and down perpendicular to usually connecting the 2 bases, but in this case just straight up and down, so that's the 12. So we're going to go ahead and multiply 3 times 15, which is 45, times 12, and that'll give us the volume of this parallelogram prism. By the way, that's called a parallelepiped, a parallelogram prism. So 45 times 12 is 540. And these are centimeters cubed. Next example. So we just looked at the volume of a prism, and we know that formula now. Volume equals area of the base times the height. Now we're going to take a look at how we would use that same formula and just adjust it slightly for a cylinder. So we know if we are using this formula, area of the base times the height, well, the base of a cylinder, if you're picturing a cylinder, the base is a circle. So I am going to substitute in for the base area into my formula. In substituting in for capital B, the base area, we'll put pi r squared in place of that. So that's what happened here. Pi r squared went in for B, and then it's still going to be times the height of, in this case, the height of the cylinder. So that's our formula for the volume of a cylinder. So let's see how it works. So here I have a cylinder, and I'm going to find the volume. Notice it says in the directions we're supposed to keep our answer in terms of pi. So volume is area of the base times the height. The base is a circle, so pi r squared times the height of the cylinder. So pi, the radius here we can see is 2, and the height of the prism, that's what connects the 2 circular bases, that is 8. So pi 2 squared is 4 times 8. 4 times 8 is 32. 32 pi. It says to leave my answer in terms of pi, so I'm going to leave pi in my answer. Now I just need units. Volume, we have inches cubed. Here's another one. So, again, volume is area of the base times height. The base is a circle. We're going to substitute in the radius. This time we were given the diameter. We know, though, that half the diameter is the radius, so that means the radius is 4. So pi times 4 squared times the height. The height of the cylinder is 10 feet. So 4 squared is 16. 16 pi times 10. 16 times 10 is 160. So we have 160 pi, and these are feet cubed. Okay, So now we're going to take a look at the volume of a cone and also the volume of a pyramid. So our formula for the volume of either of those, cone or pyramid, is 1/3 the base area times the height, or 1/3 capital B times H. So we have that same formula that's going to work for both of these, both the cone and a pyramid. Let me try to explain why it's 1/3 rather than just area of the base times the height like we had for a cylinder and for a prism. So if I were to extend these sides up further and make it a cylinder, then I obviously have more volume here, okay? There's more there, and then the cone as well. Not only is it more, but it's exactly 3 times more, okay? And you can kind of see that. It sort of looks like I have 3 cones, okay? So the 3 cones fill up that cylinder, which means I'll take the volume of the cylinder, which is just area of the base times the height, and I'll divide that by 3 or multiply it by 1/3. Okay, the same would be true for the pyramid. If I were to extend it further and create a prism, a rectangular prism, or in this case it would be a square prism or cube, the prism would be would hold 3 times as much volume as would the pyramid. So in order to get the volume for the pyramid, I'm going to take the area of the base times the height, which would be the volume for the prism, and I'm going to divide that by 3 or multiply by 1/3. So the easy way to remember that is if the figure is coming to a point, if it has a point on the top, like a pyramid and a cone do, then you will divide that volume by 3 or multiply by 1/3. If it doesn't come to a point at the top, if it's a circle or a rectangle on the top, then you will just find the volume by taking the area of the base times the height, and you won't divide that by 3. So let's look at an example. Let's look at a couple cones. So I'm going to find the volume by taking 1/3 the area of the base times the height. So the area of the base, well, the base is a circle, so that's pi times the radius, which is 4 squared. And then I'm going to multiply that by the height of the cone, which is 15. 4 squared is 16. And we're going to take 16 times 15 times pi times 1/3. I'm going to leave pi in my answer though, so just 16 times 15, which is 240. Pi. I'm going to divide that by 3, which is 80. And that gives me 80 pi. And I just need units here. Looks like we weren't given any, so 80 pi units cubed. Let's try one more. So we have a cone again. It's coming to a point, so that helps us remember we're going to multiply by 1/3. So 1/3 area of the base times the height. Area of the base, that's a circle, pi, times the radius. We were given the diameter, so of course we'll divide that by 2 to get the radius. So 1/3 pi times 5 squared times the height of the cone, which is 9. 5 squared is 25. Okay. So we're going to do 9 divided by 3, which is 3. 3 pi times 25. 3 times 25 is 75. 75 pi. We weren't given any units, so units cubed. I think we have one pyramid. So it's coming to a point. That helps me remember that when I find the volume, I'm going to multiply by 1/3. So area of the base times the height. the area of the base. Well, the base in this particular pyramid is a square pyramid. I can tell that because of the markings. So I'm going to find the area of that base by multiplying length times width, or 9 times 9, 9 squared. And I'm going to multiply that times the height of the pyramid, which is right there, 12. So I have 1/3. 9 squared is 81 times 12. We'll take 12 and divide it by 3, which is 4, times 81, which is 324. And these are inches cubed. Okay, so that's it for today's lesson. Now you can practice some of those on your own.